change how communications happen. And I want to talk about single-pair Ethernet. It's very new. It's a very new opportunity, but it's an underlying technology that right now is being used or is being applied just beginning in automotive, but also other applications like machine building. We'll talk about smart buildings, building automation like this building here, as well as process automation. So it's a technology that we're going to be talking about that has broad market significance, broad market application, and I'm going to focus on primarily smart building opportunities and touch on a little bit process automation opportunities. So when we had the introduction here, Ralph talked about innovation and the impact of innovation. Panduit built our enterprise business on the growth of 4-pair Ethernet cabling in enterprise buildings. So you think about connectivity to the desk, and there's big growth in just having Ethernet connectivity to everybody's workstation. Big change. Another really big change is voice over IP. When we started communicating, our conversations started going over IP networking. Another big growth in Ethernet networking was cameras, video cameras, moving from coaxial to now power over Ethernet. And so 4-pair Ethernet really was, we've been riding a wave. We've been riding a wave of Ethernet growing massively in the enterprise building. Single-pair Ethernet is an opportunity for us to step back and say, where else is there communications in the building that we can converge over Ethernet? And the reason why we're converging it over Ethernet is because it makes everything easier to manage. You can manage everything from a single point. Important things like security and the whole infrastructure of the communication systems. And what I want to talk about is in the building. Think about lighting, smart lighting. Smart lighting right now is primarily non-Ethernet. You have maybe a single Ethernet connection, and then most of the lights and communication over the lighting is a single pair. Same with HVAC. It's analog or serial input. And a lot of the communication. So what we're talking about, what we're looking at with single pair Ethernet is an opportunity, as we've measured it, probably to double the number of devices in the world connecting over Ethernet. Just think of the scale of that. The number of connections in an intelligent building, the number of communicating connections, only about half of them are Ethernet. The other half of the communications go over either an analog signal or a serial digital signal. Somehow that data ultimately needs to get somewhere. Somehow that data wants to turn into Ethernet. Single pair Ethernet gives you the path to connect all of those devices to Ethernet. So we're talking about something that's has pretty large potential impact here. One of the biggest changes, one of the biggest differences between single pair Ethernet and 4-pair Ethernet, if you look at it from they're both Ethernet, is obviously a single pair, but the channel for Ethernet has always been 100 meters. With single pair Ethernet, a part of the enabling is the standard allows you to travel a kilometer over a single wire, and that's powering the data. So that's contrasting it from 4-pair Ethernet because it's Ethernet, and everyone thinks, okay, single pair, 4-pair, this is it's all Ethernet. But the more valuable comparison is actually to field bus. What does field bus infrastructure look like? And you'd be surprised, most field bus infrastructure is a single twisted pair. It's a balanced twisted pair of conductors. Often it's shielded, and 100 ohm impedance, so there's a certain electrical design parameters to it. The connectivity for this analog and serial field bus is almost always screw terminals. The bandwidth and the distance, they're typically very engineered systems. Field bus and serial are. You need to have knowledge on the system. It's not plug and play. You can go up to a kilometer with these field bus systems. At a kilometer, you're measuring the bandwidth in kilobits. In IT, we usually talk in at minimum megabits or gigabits, but you're talking kilobits or bits in the analog and serial space. So you can go up to 10 megabit for serial communications, like Profibus, but you're distance limited to about 100 meters then. So looking at field bus, single pair Ethernet is very comparable in the physical infrastructure. It looks the same. It's a single twisted pair. It's balanced. It's shielded. You can connect over a terminal strip. You can. They do it. You can do that with 4-pair Ethernet too. We think that's going to evolve to plug and play for a number of reasons. And the nice thing about single pair Ethernet and why it's so exciting is you don't need to be a communications expert. How many here is it like an engineer communications expert? No one. But you can still plug in your computer and get Ethernet, right? Yes. Right. That's where this is going. That's where this is going. Make communications plug and play. You shouldn't need to be a communications expert to get data out of a sensor. Think about how much this could change the industry. So the point here is single pair Ethernet is not going to come to a cubicle near you. Single pair Ethernet is going to connect the other hundreds of millions of devices that are currently analog and serial, that if you start looking, and it can be a curse, if you start looking through the building from this perspective, you start seeing devices everywhere. We talk about the digital ceiling, we look at all the devices on the wall, you start seeing devices everywhere that communicate. Most of them don't have an RJ45 port, but all of them communicate in some way. That's what we're talking about, and that's the opportunity here. So what I'm going to talk about is 2 applications. We're going to focus on just smart buildings and process automation. Spend a little more time on smart buildings. I think there's a massive amount of opportunity in smart buildings, and it's just starting now. If you haven't heard it, you'll start hearing about it. And you might be, because you're in the room, the first ones talking about it in the industry, but there's a massive amount of opportunity in the smart building. What's driving it? Who has seen this? This is actually an email I got from HR. Our strategy for smart building, you can say, is happening to us. We're moving to hybrid work. Our whole life and how we use commercial buildings is fundamentally different now. I go into the office to meet people, to communicate, to talk to people. I don't go into the office to put my head down and get work done. I can do that more effectively at home, frankly. It works. We have to think differently about how we do work. So hybrid work is going to impact what a smart building looks like. What's a smart building? A smart building is a structure where technology is integrated to manage meeting the needs of people. It's not complex. Your purpose for the building is the people in it. And that technology is going to give, safety and security, collaboration, comfort, energy management, convenience, all of these things. The purpose of it is people. And the goal, we're in a hotel, right? So the goal of this hotel is to make you want to be here. They want the atmosphere and everything to draw people in. What we're seeing is commercial buildings now have to do the same thing. They, if you will be competing for the time of their employees, so their employees want to come into the office. And that all happened fundamentally that happened in 2 years. Now buildings have to make you want to come in. And there could be some measure of, you have to come in this day, but fundamentally that's what's happening. So what can intelligence do? Really two things. You're going to either better meet the physiological needs of people, the soft things, or you're improving the efficiency of the building. So think about efficiency, very easy. If we're in a hybrid work situation, less people are going to be in the office, how can we improve the utilization of our floor space? We're talking hoteling, we're talking about reducing the energy usage in certain ways, improving collaboration with tools like Atlona provides, and then meeting physiological needs, things like light tuning, improving personalization, making it easier for you to sit next to and collaborate with your colleagues. Technology can simplify that so you don't even realize it's there. So these two things, we're going to see the entire building system change to really focus on these things. Some of it's going to be money driven. Companies are going to be looking at their building and saying, how do I improve utilization? But they're also going to be talking, HR is definitely at the table, and they're going to be talking about, I want them to want to come into work. Those two things. How can we do that? Look at all of the things that communicate. This gets back to the first thing we talked about. All things that communicate. Communications to the desk, conferencing, scheduling, cameras, wireless. All of these things are currently on Ethernet. This is the heart of Panduit's enterprise business, right? Other things that communicate: security, access control, lighting, HVAC, life safety. These are typically, you can connect these to the internet, but typically as a broad market, these are serial communications, these are analog communications. Not only they're serial and analog, they're all segmented. So I can't have my IT people come in and say, I need to provision an access or a security system or a lighting system. I have to call an outside vendor typically to do security, but I can't call the same vendor. If it is the same vendor, it's going to be a team looking at security access control. I'm going to call a different team, a different company to look at the lighting system, a different team to look at the HVAC system. So what do I do today if I want to create an intelligent building? I can do anything in the world I want. The technology is all there. I can make the lighting system talk to the wireless or conferencing or light. I can make it all communicate together, but how do I do it? I hire another integrator and install a gateway above the systems to communicate information from one system into the other. So I can do anything, but it's rigid, it's fixed. It can't really be changed very easily. The objective of convergence and what single pair Ethernet is going to drive is convergence of the entire smart building. So for example, I can have the HVAC system look at the conferencing and scheduling system so that there is no HVAC going into this room unless you have it scheduled, for example. there are capabilities like that you could rigidly fix, but what about having a building that can just do that and manage the energy efficiency in this room, for example? What are the possibilities if all of your smart building systems are talking together? That's the type of opportunity that single-pair Ethernet can provide. So that was smart buildings. Let's look a little bit at industry. In industrial automation generally, there's been a trend, a moving trend towards getting data accessible in the cloud. So you can manage all of the thousands of devices or hundreds of thousands of devices across your plants across the world in the most efficient way. This is nothing new. In fact, in discrete automation, HMS, Industrial Networks, has a report that they put out every year. The latest one, I think there's more than I think it's around 70% of field bus applications are already Ethernet. So this has made a lot of progress already. Ethernet is widely used in industrial. There's an area where it's not used, and that's in process automation. The reason for it is explosion hazard. Ethernet can't be used in explosion hazard environments, and that drives the need in industrial. So what single-pair Ethernet does is it replaces a huge amount of usage for field bus, HART, Profibus, those applications, and gives you the ability to run in these process plants. So really in industrial, what you're looking at single-pair Ethernet, having an opportunity to drive Ethernet deeper to the sensor, all the way to the analog and serial applications, especially for process. That's where it's being driven. And the cool thing is, Panduit spent a lot of time on the standards bodies. We've been working on this for 5 years. So we have engineers that have been deeply involved in this for since I think 2015, 2016 timeframe. The cool thing about process automation is you have competing organizations, not only competing companies, but competing organizations like, you're familiar with the Profibus, Profinet organization. They're one of their biggest competitors is ODBA in North America, and there are a number of others. You have Siemens and Rockwell Automation actually all working together. And they formed, this is a slide from the Ethernet APL, they formed a coalition together, and they built a specification around the use of single-pair Ethernet, the use of Ethernet in process applications. So this was just launched last year. And at ACHEMA last year, about 6 or 7 different vendors released product that communicates over single-pair Ethernet. So just, like I said, we are on the ground floor of this, and the process industry is probably further ahead. I think some other industries will catch up shortly, but we're very much ahead of this. And again, I talked about gateways and building automation. Gateways are used extensively in industrial because in building automation, often it's nice to have to allow systems to communicate. In industrial automation, it's absolutely required that different systems communicate together. There's a very large business in industrial managing and deploying these gateway systems to allow the different machines and different subsystems to talk together. With single-pair Ethernet, the opportunity, the communication is much more seamless. So you see it right from the Ethernet APL slide that they allowed me to borrow so graciously. Gateways required for low-speed digital and high-speed digital if you want to make data accessible. With single-pair Ethernet, it's Ethernet. You don't have to break up the packet and rework it and send it elsewhere. It's a packet. It can be routed anywhere you want to. Now all you have to do is manage security, which you have to anyway. So that's single-pair Ethernet in building automation and in process automation. I hardly need to make the case for change. The customers make it for us. They want to use Ethernet. They're loud in their purchasing behavior. It improves their network security. It makes it easier to route and manage not only security but also visibility to the systems. It allows them to use standardized tools. So if you think about the enterprise-wide tools that are being used for cybersecurity, for example, when you put systems onto Ethernet, they automatically almost can use those same systems that were built for IT cybersecurity. That's not to say it's automatic and easy. I just talked to a customer yesterday that said Microsoft certificate on the computer expired, and so it's an emergency. I have to get that certificate running, or all of my IT stuff goes down, or all of my operations go down, basically. So there are definitely challenges in using IT communications in industry, but it's not a question of whether you do anymore. When I started working on this about 15 years ago, it was a serious question. Will Ethernet play in industrial? We weren't sure. Panduit believed that it would be very important, but there were many loud voices in the market that said, no, we are investing in other technology, not Ethernet. That is no longer a question. Everybody in industrial, in building automation, everybody is seeing the value of Ethernet communications. Now the question is, how deep can we go? How efficiently can we go deep on everything communicated? So next up, how do we get there? The cool thing with single pair Ethernet going to the devices, going to the sensors, is that most of the work is already done, really. So you look at Profibus as a massive protocol used in both discrete automation and process automation. Profibus has been around forever. It's used everywhere. Single pair serial communication system. Profinet International took it upon themselves, they even renamed the organization, they took it upon themselves to take the application layer of Profibus and build it on top of an Ethernet stack. So you already have the application layer of Profibus on an Ethernet stack. So you can run Profibus today over any Ethernet communications to some extent. I think the standard is 4 pair or 2 pair for a lot of it, but you can run Profibus over fiber optics or copper communications. What that means is all you need to do at the switch level is change the physical layer. The application layer is already built. Change the chip, the physical layer chip for communications, and you can now take that Profibus application of Profinet and run it on single pair. It's all that work's already done. Similarly with, say, building automation in HVAC, BACnet is one of the most used protocols. And BACnet was an RS-485 based application. Now BACnet runs over IP as well. So the physical layer, you can change the physical layer and still run that same application layer. So where do we go from here? Our goal, our objective at Panduit, working with single pair Ethernet, is to help end users understanding what we just saw. The future is Ethernet. Single pair Ethernet very clearly enables that Ethernet future. So given that, how can we help end users plan? We've been doing this a lot with a number of different applications. And what we want to do is, when a system is put in place, how do we, that system is going to be in place for 20 years. For industrial, for building automation, the cabling is put in place and lasts for a long time. How do we help them future-proof? And when we talk to somebody that deploys field bus, the question that I ask them is, how do you know when your system is reliable if you're putting in a field bus? Is it when you specify all the components? and check they're installed correctly? Is it when you run a continuity and signal quality test? And run down the list. Ultimately, they're not confident it's going to work until it's working at full service load. There is no way to really be confident in a field bus system until you're running at full service load. And this is a serious concern, even with Profibus as an application. It's difficult, from this quote, it's difficult to differentiate between a physical layer problem and a device problem. That's the first problem, that's the first challenge that needs to be, if there's a problem in communication, they have to decide, is it a physical layer issue? Was it just terminated wrong? Screw all the 100,000 screw terminals? It's a real debug step.